Hey everyone, LaDell here. Welcome back to my Spindle Chick Chat. Today we're going to be talking about how you'll know if your spindle motor is defective, so let's dive on in. Detecting spindle damage early can save significant time, costs, and production delays. Here's how you can identify potential problems. Listen for unusual noises. Grinding, squealing, or rattling noises during operation can indicate spindle damage. Investigate any atypical sounds promptly. Check for vibration and runout. Excessive vibration or increased runout, which you can detect with sensing devices, may signal spindle irregularities. Assess cutting quality. Poor surface finishes, dimensional inaccuracies, or tool breakage might mean the spindle is damaged or misaligned. Monitor temperature. Excessive heat or fluctuating temperatures can be a red flag. Regular temperatures checks are crucial to spot abnormal thermal behavior. Watch for unpredictable performance. Random stops, sudden acceleration or deceleration, or unexplained changes in operation patterns can indicate spindle issues. To diagnose spindle damage accurately, use these techniques. Vibration analysis. Monitor vibration levels in multiple axes to detect excessive vibrations. Use dedicated tools and software to analyze the vibration spectrum. Thermal imaging. Thermal imaging cameras can help you spot temperature variances on a spindle surface, highlighting areas of concern. Runout measurement. Measure runout at the cutting tool or workpiece to identify inconsistencies, indicating spindle damage or misalignment. Periodic inspections. Conduct routine spindle inspections, including disassembly and visual checks to identify visible wear, corrosion, or other signs of damage. By staying vigilant and using these diagnostic methods, you can maintain spindle health and ensure optimal CNC machine performance.